Welcome to Biology My Passion. I am Soumya Harikrishna. We are learning the chapter Motion. We learned up to the graphical representation, dt graph and vt graph, what all parameters we can obtain from these two graphs. Now we are moving on to equations of motion. There are three equations of motion. V is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to 2as. Let's see what all these symbols mean. You know that already. What is u? U is the initial velocity. That is when an object is starting, what is its velocity? Suppose an object is starting from rest, then u is 0. Otherwise, there will be a particular velocity we are considering at that moment. Then final velocity is represented as v. Again, if an object is coming to a halt or stop, final velocity will turn 0. Then A for acceleration, T for time, S for distance travelled. So when you look at the first equation, V is equal to u plus at. Here we are trying to connect velocity and time. Whereas S is equal to ut plus half at square. Here we are trying to connect distance travelled with the time. But when you remove these t from these two equations, you get the next one. V square minus u square is equal to 2as. Here we are not considering time. So before we start using this in numericals, let us understand how could we get these equations, or how did we derive these equations. So we can obtain or derive these equations from a VT graph. What is meant by a VT graph? Velocity time graph. In that, in the y-axis we are taking the velocity, x-axis we are taking the time taken. In this graph, an object is moving with the acceleration, that is uniform acceleration. It's starting from a point A and it is reaching a point B. So initial velocity is seen on the y-axis, but you know the object is not starting from 0 velocity. So the initial velocity u is not equal to 0 here. So we can take this distance as u, because from 0 this much distance is the velocity attained by that object initially. Now it travelled up to B. So if I connect B here this is the value of a v, or the final velocity. So from initial velocity u, the object attained final velocity v. This is the difference in velocity. What is the time taken to reach here? So if I draw like this, see the y-axis. So velocity increase this much at time t. So this is the time OC. Now I am drawing a line parallel to this d also. Okay, so now let's see the first equation. V is equal to u plus at. We have to see velocity. You know, velocity as per this, starting from 0, final velocity we reached here. So that is corresponding to BC. What is BC? It is sum of BD plus CD, right? Or DC. Now V is equal to BD plus, you know, this CD is corresponding to OA. But what is OA? OA we already told, that is the initial velocity. So BD plus U. So V is equal to BD plus U. We can consider it as the first equation. Now let's consider acceleration. How do you find acceleration from a VT graph? Slope of the VT graph is the acceleration. So acceleration is the slope of the VT graph. What is meant by slope? Quantity on the y-axis, or difference in the y-coordinate, divided by the quantity in the x-axis, or difference in the x-coordinate. So here difference in the y-coordinate, if you say, you can say that BD is the difference in the y-coordinate, or change in velocity from u to v, it is BD. Upon, what is the change in time? AD. But AD is corresponding to OC, so I am writing OC. So now I can write A is equal to BD by, what is OC? OC is the time. So if I rewrite this, what is BD? By cross multiplication I know BD is 80. This is equation 2. Now I am going to use this BD from equation 2 into equation 1. So V is equal to U plus, what is BD? 80. So we got our equation. Okay, so we are finding velocity, which is total velocity is BC. BC is BD plus CD. BD plus CD is OA, which is U. So BD plus U, that's equation 1. Now acceleration is change in velocity by change in time. Change in velocity is BD, change in time is AD, which is equivalent to OC, that is time. So we can say BD is equal to AT. If you substitute that, we get V is equal to U plus AT, that is our first equation. Now let's derive the second equation, S is equal to UT plus half AT square. So here we have to find the distance travel. So VT graph, from VT graph, how will we find the distance travel? By finding the area under the VT graph. So here area, if you see, it is totally the trapezium. So two ways we can find out the area. Either you can find out the area of the trapezium, or you can find out the area of this triangle and the rectangle separately and a angle. So we have to see what way you have to use in order to get this. Now we can find out S is equal to area. So area means what? Area of the rectangle OADC plus area of the triangle ABD. If you add, you will get the total area under the this VT graph. What is area of rectangle OADC? OADC, OA into OC. Plus area of triangle ABD will be half into BD into AD is equal to, what is OA? OA is equal to U into OC is nothing but T plus half into, what is BD? BD is the AT. Because previous equation when we derived, we found that slope of the graph is acceleration. So from that we found BD is equal to AT into, what is AD? AD is the time T. So now we can get UT plus half AT square. What is it? Yes, so this is our second equation. S is equal to UT plus half AT square. Now we are going to derive the third equation. V square minus U square is equal to 2AS. So S is equal to area of trapezium OABC. So here we are taking the trapezium as a whole. So together we can take. So what is the area of this trapezium? The half into the parallel sides. Which are the parallel sides? OA plus BC into height. Height is a OC. So half into, what is OA? OA is U plus what is BC? BC is V into what is OC? OC is time. So we can write U plus V upon 2 into T. Okay. Now look at this equation. V is equal to U plus AT. So from that equation, that is velocity time relation, we know time is equal to, if you bring this U to the left, V minus U upon A. T is equal to V minus U upon A from this equation that we are substituting here instead of T. So what will we get? S is equal to U plus V by 2 into V minus U by A. So this is V plus U into V minus U. So what is it? V square minus U square by 2A. So when you cross multiply, S is equal to V square minus U square by 2A. Therefore, V square minus U square can be written as 2AS. This is our third equation of motion, which we derived from the area of the trapezium. Hope you understood all the concepts of this chapter very well. So please learn it very well, practice it. I will come with another video having more questions and numericals for your practice. Please like, share and subscribe to my channel, Biology My Passion. Thank you for watching.